Hello, lovely people. Before we actually start, need to vent about something. So amplifier testing, the only amplifier testing that you can see online, and this is like, it pisses me off all the time. Now, the only thing what people do is they put an amp on a dyno and measure its maximum output and nothing else. And what they do is, and again, I have nothing against people who do amp dynos. Do it, like, do whatever you want. However, it doesn't tell you absolutely anything about the actual amplifier performance. And the only thing that it tells you is just one number, which is its maximum output at a certain voltage, and nothing else. And that kind of grinds my gears, because you cannot tell, like, if an amp does rated power, it's a good amp. If it doesn't rated power, it's a bad amp. No, it's like, no, just no. So what I decided to do is I decided to test amplifiers by myself with what I have and without like audio precision and that kind of stuff. So before I did all of this, I did quite a lot of research. That's what I was quiet for the past week. I read a lot about amplifier testing in DIYMA, like forums. I watched Amir from Audio Science Review. I watched, what's that guy's name from Audioholics. They're using audio precision to test amplifiers. And obviously I'm not gonna be able to afford anything like that. So this is gonna be quite a few parts video. So in the first part, I'm gonna tell you all about the equipment that I'm planning to use, why and how is everything connected and everything. In the second video, we're gonna jump into the laptop and see the actual measurements, what we will be testing with this, what we're gonna be measuring, why, the settings and everything else. So let's go through all of this. So when you're testing an amplifier, you want to test its performance. So first thing you need is something to measure with. And the other thing, especially if you're using like a car audio amplifier at home, you need some kind of a power supply. So let's start from this side, which is the power supply. So this is my bank of lithium. It's quite an old lithium, but again, it's fine for this purpose. It's janky, whatever. I have aluminium bus bars, DIY, everything is DIY. This bank of lithium cost me, the lithium itself, 25 pounds per cell, so 100 pounds for the banks. This is an active balancer. I didn't buy a BMS at the moment because BMS is like 100 MBMS. 4S would cost me about 80 pounds, so it's almost the same like the bank. And I bought this for like 10-12 pounds from AliExpress, and it's just to balance out the cells, so that's fine. Then I had some stuff. Basically I used everything that I have laying around. I have these leads. These are 4 gauge. I'm gonna tell you why they're so long. Actually, I can tell you now. So my plan is not only test the performance of an amplifier that we can actually measure, but to test some myths. So for example, one myth is that if you run RCAs next to the power wire, you're gonna have a lot of noise and interference, and this is exactly what I'm gonna do. So I have quite a long lead because I had a spare wire. I didn't want to chop into small pieces because I will be reusing it, so I made it quite long. It's like, I don't know, maybe like 3-4 feet. So I will be literally taking an RCA, a shitty bad RCA, and wrapping it all the way around the power wire and see if it makes a difference, if it introduces noise and stuff. So we're gonna try to debunk or verify some myths. Where was I? Okay, so this cheap. What I bought is a circuit breaker and not a fuse. So in the beginning I thought you put a fuse. However, then I thought, if anything starts smoking, I won't have any time to disconnect the bolts or like these. So instead, I have a circuit breaker, which literally with one press of a button, I can disconnect the circuit. And in case something happens, it's going to be just like that. So I won't have to look for keys or whatever. So in my opinion, is just for safety. And you will see I have loads of fuses everywhere. So I have these power wires 4 gauge for testing the 4-channel amplifiers, because most of them will have 4 gauge inputs. Then, so positive, negative, it goes there. From the positive, I hijacked another lead for remote. So basically I can, even if I have power running, I can connect and disconnect the remote with a flick of a button. Now you see a few other wires. One of them is voltage meter. So again, it's janky. It's fine. I had it from ages ago. So what I did, if I press this, it activates the voltage. So now it's 13.2 volts. So now this battery is live. Then if I want to connect the amplifier, I'll just press this. It engages the circuit. Now everything is running through the cable, and with the flick of a remote, the amp goes on and off, on and off. So I can control the amp on off, and in case something starts smoking, I just press this button and everything goes out. Easy peasy, yeah? And yeah, so to charge this battery, so this is a half a C charging and 1 C discharge. So it's 100 amp hours. So it can supply, in theory, 100 amps of current. That's why the circuit breaker is rated for 100 amps as well, just in case. And I definitely won't need more for testing 4-channel amps, because this one is 60. The bigger one that I have is 70 amps, so it's plenty enough. Now to charge this lithium, I bought this. So this is from China. I paid £12 for it, and this is a 40 amp power supply. So it's a switching power supply. It's very poor, like everybody says it's very poor quality, blah blah blah, that kind of stuff, but like I think for charging lithium is gonna be fine. So this one has a small adjustable dial here, and it adjusts the voltage, and I checked. So all the way down it gives me 10 volts, all the way up 14.7, 14.8. So basically this power supply, it's 12 volts, but it does 10 to 15 volts. And what I have is, I have the power wire that goes into the mains. So you have live, neutral, ground, and then you have 3 pins for negative and 3 pins for positive, because it's 40 amps. So instead of using one big wire, you can use a few smaller ones. And I just used, because I had some I think it's 10 gauge or 12 gauge speaker wire, and I just doubled it up. So 2 for positive and 2 for negative. And I have these lugs that go on the battery when I need to charge it. This is another fuse, because I like to overcharge. So this is a 50 amp fuse in line with lugs as well. And then I have another lead, which is from a single 12 gauge wire. This will be for testing smaller DSP amplifiers that I have, because I have the Alpine, 2 of them, and I have the Nakamichi. I will want to test them as well. So this, again, this just pops on the battery terminals, and then I can connect positive, negative, and remote. And again, exactly the same remote with the switch that I could turn on and off. I can connect these wires that usually they come in this plug, and you have like these bare wires. So basically I just need to find the positive, negative, like this one. The yellow one is positive, and just screw it in there. And I can test small DSP amplifiers, because they will need much less current, much less power. So this is plenty enough. And even like 4 gauge test these is overkill. Okay, so this is a power side. I might be able to test monoblocks as well, so smaller one, because my Alpine does like 1000 watt, 900 watts, and it has like, I think it has 100 amp fusing. So I don't know if the circuit breaker hold, but what I could do, because in theory I have 100 amps plus another 40, so I have 140 amps of current available. And in case this keeps blowing, I'm just gonna replace it with a ANL fuse with a higher rating, like 170 amps or whatever. So that's in the plans. Maybe, we'll see. So this is the power side. Now let's have a look at the load bank. So in order to test the amplifiers, you need to put a load on the output. So basically you need to test them with ideally speakers connected or with some kind of static load. So all the testers use a static load bank, and this is exactly what I did. So this is an old in-phase amplifier that I modified. So this was supplied to me by James, just gave it away. Thank you very much, James. And what I did is, you'll see all of these. Let me show you what I did. I got these resistors, again, AliExpress. So these resistors are 100 watts at 4 ohms. So I have loads of them, and basically what I did, so I will need 4 channels to load, or 4 channels, and I went a bit overkill for this because why not? So I have 4 resistors per channel, so it gives me 4 parallel, gives me 2 ohms, another 2 ohms, in series 4 ohms. So that's 4 ohms, 400 watts, because it's 4 resistors, and I have 4 for 4 channels. So I have at 4 ohms 400 watts, and then in 2 ohms, because 4 channel amplifiers are rated at 4 ohms each channel, then 2 ohms each channel, and bridged in 4 ohms. So the plan is I'll have 400 watts per channel into 4 ohms. Then I hijacked a wire from here as well, and I have these quick connects. So I don't know if you will understand. Basically, so this is 3 connectors per one kind of mini bank, and first and third is gonna give me this and this, which gives me 4 ohms. And first and middle one is gonna give me this and this, which is only 2 resistors in parallel, which gives me 2 ohms, 200 watts. So if I connect 1 and 3, I have 4 ohms. If I connect 1 and 2, I have 2 ohms. So I can wire either all 4 channels either in 4 ohms or in 2 ohms. And then for bridging, because I will need more power, I can parallel, like this hole is 4 ohms and this hole is 4 ohms, parallel, and I have 800 watts into 2 ohms. So two banks of 800 watts into 2 ohms for like bridge testing. And then, yeah, so this is the load. And then I have piggybacked because I will need to measure, and I will be measuring with the Focusrite audio interface. So now we're gonna go to the actual measurement equipment. Everybody who's testing amplifiers, they're using audio precision. I cannot afford it because it costs 40 grand. And for this purpose, I think this is gonna be plenty enough. Because the main thing is the floor noise and the THD of the item itself. Because when you're measuring something like an amplifier, a DAC or whatever, you want the measuring equipment to have less noise and THD than the actual item that you're testing, because otherwise you will be testing this instead of that. So I did some preliminary like measurements, and the floor noise of this goes down to like minus 110, 120 dBs, and typical amps have a much higher floor noise, like minus 80, minus 90, minus 70. So I will have maybe like 30, 40 dB headroom, which is perfectly fine for that. Now, the audio interface has a few inputs, so instrument and line. So I did check the specs on line input. It has better performance, however, it needs a bit more signal. The audio interface itself outputs 1 volt of output, and that 1 volt is gonna go with the RCAs into the amplifier, and I will be able to adjust with the gain up to like clipping point or over clipping point if I will need to. However, I don't have the ability to supply full 4 volts into the amplifier, because if you want to keep the gains all the way down, you need to supply for these Alpine amps 4 volts, and this one does only 1 volt. So it's kind of yeah, but I think it's gonna be fine. I do have a loop back, because for testing like harmonics and stuff, you need a loop back. And then I have this input that comes from the speaker wire that comes out of the amplifier and with the load. So on maximum output, this should give me, I don't know, maybe like 20 volts, 25 volts. Now, obviously, the audio interface cannot take 25 volts. So what it needs a voltage divider. And actually, voltage divider is a simple thing. It's just 2 resistors. You'll not be able to see it, but it's basically one in series with the positive, and then one across positive and negative. So I chose values of 22,000, so 22k ohms in series and 330 across. And what it does, this voltage divider, it gives me a voltage reduction of about 66 times. So I did test this input as well. So this input takes up to 1 volt as well. Something like if you reach 1 volt, then the input starts clipping. So I need a voltage lower than 1 volt. So if this gives me about 25 volts out, if I take those 25 volts and divide it by 66 with this, I get something close to like 400 milliamps. So millivolts, sorry, 400 millivolts, so a bit less than half a volt. If I will want to push it just to see the clipping up to like 30 volts or whatever, then this is going to be up to half a volt. So it's still going to be on the lower side of the input, and I'm going to be 100% sure that I'm not clipping the actual input of the interface. And I might play with this, especially if I will be testing a smaller signal like 1 watt of power, because most we will be talking about the actual measurements, how, when, what, or why, but you'll be testing on maybe 1 watt, maybe 5 watts, and on that you have lower voltage, so maybe like 2 volts or 3 volts or maybe 5 volts. So 5 volts I will need only divide by 10. So instead of 5 volts, I would have half a volt. So I will make another one with less division, because this is specifically to test full power, 30 volts. So it's gonna bring the voltage down. Because what I want is, I want to have this gain knob close to minimum as possible, because again, I did my testing and I will show you that if you have gain higher, the input, the noise is higher as well, and I want the noise as low as possible. Exactly the same with this. Like if you would do like a combination of lower output voltage that goes into the amp with higher gain, you would have the same signal but with more noise if you compare it to high voltage and low gain. Then you would have less noise. So I did some testing with my home amplifier, and it was a pain, because like home amplifier has a fixed gain structure, and you need, so this, my Yamaha that is there, so I did testing with it. However, it has on the input, it can take only up to like 200 millivolts on some inputs, so I had to like lower the volume on the interface, so instead of 1 volt I would get only 200 millivolts. So it was a lot of playing, but with these amplifiers I think it's going to be a bit easier. So I know there's a lot of numbers, and I know that some of you do really like numbers, so this is really technical stuff, and I personally, I just love it. I love it. And we're going to go into the laptop and I'm going to show you all what we will be measuring. That is going to be even more technical, and I just love it. But basically, this is a setup, like the physical setup of how all the connections are and how I'm planning to measure everything. Now, if you have any advice, any tips or something, if I will do something, if I will, should do something more different, like change something to be more safer or stuff, please comment below. But I was aiming for like overkill and maximum safety. So I have loads of fuses everywhere. I have overkill bank that I know that is not gonna overheat. Oh, by the way, so this is like ribbed. And what I did under these resistors, I have a thermal pad that is transferring the heat. So you can find it like in the amps, under transistors, like the thermal pads. So those thermal pads are squashed into the gaps, and basically it's flush. So it's not like it doesn't, the resistor rests not on the ridges, but it actually has a full contact with this. If it's gonna overheat, I doubt it. I can put a fan, but yeah, I think that's gonna be fine. So yeah, this was a video about my physical setup, how I am planning to test amplifiers, and the next one is gonna be in REW in the laptop to see how we're gonna measure things and what we're gonna measure things and why. So if you have any comments, please comment below, and thank you very much for watching, guys. I will see you in the next one.